Hello and welcome to Aerospace and Mechanical Lab 1. This is going to be the recording for the first lab. In this lab, we are going to do an uncertainty analysis and move on to a metal hardness test followed by a rubber sample hardness test. For the first part of the lab, we are going to use this 1 by 2 by 3 inch block. So each side is 1 inches. We are going to use a caliper to do 25 measurements of each side of it. And eventually at home, when you are working on your worksheet, you have to give us the confidence interval for each of the side measurements and propagation of uncertainty into the volume of the block calculation. The first thing you want to do for the first part of the lab is to, of course, know what the caliper is. If you don't already know, a caliper is essentially just a more accurate ruler. On the sides here, we have, this is an inch-based caliper. We might also have a millimeter-based caliper. On the sides, we have all of the numbers. You will see, I'm not sure if you see this in the recording, but if you come to the lab, you will see that we have bigger numbers, 3, 4, 5, 6. This represents 3 inches. And then we have smaller numbers, 1, 2, 3, 4. So 3.1 inch, for example. This dial here, if you open it up, it moves, right? Each line is of the dial represent 0.01 inch, that is 0.001 inch, that is given right here. So if this is your value, you're going to come here. Let me actually go past 1. If the value you're measuring is this, I see 1 here, so you have 1 inch, and then we have 2, 1.2, and the value I read off of the dial is 92. So my measurement is 1.292 inches. And what I'm going to do is I'm going to make the measurements of each side of this block. Again, 25 times. That would be your lab, each side of the block. You have to record this data in a table, of course. You have to present that table in your worksheet, and you are going to calculate the confidence interval with the confidence level that we have given you, and eventually you have to propagate that confidence level into volume of this block calculation. You want to keep in mind, to calculate volume, we of course have to multiply this side by this side by this side. So technically the volume of this block is 6 inches. If the caliper you're using is millimeter based, you can do all of your analysis in millimeters. You do not need to convert anything to inches. Next part of the lab is the metal hardness measurement. We are going to use a Micromet micro hardness tester. This is a Vickers tester that is going to help us calculate the hardness value for the metals. We also have another type of this instrument that we are going to go over after this. So to set this up, of course, you want to place your sample here, and you can move the lever. You can move it up and down using these levers. You don't need to use these levers because you can just easily move your sample to make sure it is underneath your microscope or the lens or the indenter. Okay, so the idea is we are going to set a force. Force can change from this side. It can go from 10 grams of force, very important. The unit for force here is 10 grams of force or kilograms of force in general. We are not dealing with newtons here. Okay. We usually put it on 1 kilogram of force because we want to make sure that the indent is big enough so we can see it. It is going to be easier for us to see. That's how with this knob you can actually set the force that you're applying. And with this knob you can change the light. The lighting is the most important part of the analysis because we are going to see later on that using the lights we can actually see the indent, and we can change the time, the load time. That wouldn't really change the hardness value, but if you make sure your load indentation is applied over like 20 seconds, you are going to have a better indent. and it's going to be easier for you to make the measurements. Of course, there's another button here. There's a turn on and turn off button. Right now it is on. We can always turn it off at the end of the experiment. So we're going to do the experiment with this. The next shot, you are going to be a little closer, and then we are going to move to the second instrument that we have. So if you are using the second instrument, you want to go forward in the video a little bit. Okay, so you're ready to do the experiment. The device is turned on. You want to make sure that you see this green dot on your sample. But that means that the light is being transferred to the sample, and that lighting is the most important part of the situation. If you don't see that green light, there is a turret here. You want to make sure you are on the lens of the turret. When the green light is there, you want to change this to the indenter. Okay, and you want to move it up using the levers on the side. Of course, you should make sure that your surface is as clean as possible. And you want to touch the surface a little bit. You don't want to press it, but touch the surface so you can make sure that you can create the indent. Okay, when the surface is touched, there is a loading button on the microscope. You can just press that loading button. Press that loading button, and you just wait for the loading to happen. We are doing 20 seconds of load, so we have to wait a little bit for the loading to happen. And I want you to do this loading a couple of times. We can shoot for 3 to 5, so you can actually do a statistical analysis. And there is a green LED on the microscope. When that green LED turns off, that means that the loading is done. I'm still waiting for it to turn off. It will be a couple of seconds. It is done now. The loading is done. What I'm going to do is I'm going to, again, move the sample. So when you're done with the loading, you want to go to the M40 lens that we have there. You want to move the turret to the M40 lens. You also want to make sure that you actually don't move your sample, otherwise you won't be able to find your indents, right? And then we have 2 knobs on the visor. Like one of the knobs, if you look into the visor, you're going to see 2 lines. One of the knobs moves the 2 lines with each other, the knob on the left, and the other knob is going to help you make the measurement. So again, you can rotate the visor if you need to align with your dent, and you can move the 2 lines that you see inside the visor. If you have to, so at least one of the lines aligns with one side of the indent, and then that other side needs to be aligned by moving this knob, this one line. This will move the one line. When that line is aligned, you are going to read the data of your dial right here. Whatever value you read must be multiplied by 100, and that will be in micrometers. So if you see if you measure a value of 2, for example, that value is 200 micrometers, right? Okay. But if you look at closely, we have black lines on top and red lines on the bottom. If your knob is right here, for example, it is after a red line. Your value would be 1, and you read the closest red number, which is 47. So 147 micrometers. If it's closer to the black line, the value you read would be 100, and I guess I made a small mistake here. of course, the first, like, let me actually explain this again. Okay, this might be a little confusing. You have, we are very close to the value of 1 here, and we are after a black line. So I look at the black number. The value of I should read is 102 micrometers. Okay. After the first line, first red line, the value I read should be the second value, which is 142 micrometers. Then after the second black line, which is the smaller, the value you read, if you're after the second black line, should be whatever number you have on here plus 150 micrometers. So the value I have right here is 150 plus 23, which is 173 micrometers. And then the second line is whatever you have, again, plus 50. But this time, the red number. So the value I'm reading right here, the red value is 44. 150 plus 44 would be 194 micrometers. And if you have any questions about this, this might get a little confusing. You want to make sure you take a picture of these numbers so you have it with you, and ask your TA what the correct value is. Or if they couldn't help you, you want to make sure you reach out to me, come to my office, and I will give you the correct numbers. As I mentioned earlier in the video, we have 2 different types of devices for the Vickers hardness test. The second one is the phase 2 micro Vickers hardness test. This is a bit more advanced, and you don't really need to change any of the settings that you see here. You want to just make sure that the turret is placed on the correct spot, and you have to just apply the load. You don't change the load or anything. Just move the levers and apply the load whenever you are ready. How do we apply the load? There is a red button right here that is called the start. Of course, you have to make sure that your turret is touching the surface of the indenter, and when it does, you press the start. It will start loading. This time we have a red LED, and while we are loading this, I just want to make sure that the light on this microscope is a bit finicky. Sometimes it turns off, sometimes it's not as strong. So what we do usually is we use our cell phones. We just put it on top of here to make sure we are providing enough light that will make the whole things easier. Okay, so you definitely need to use your cell phone to make sure you actually have the correct light. Okay, so the loading is complete. We want to change this to M40 or any lens that wouldn't really matter that much. And the knob on this one is much easier to read. It's just a regular dial, and it gives you the hundredths of again micrometers. So if you see the value of 4, for example, you have to come here and then 425 micrometers for the indents. And one thing that I didn't mention over there, and we can't really record the inside of the visor, but if we do find a recording online, we'll make sure you actually see this. You have to play with the lever a little bit. I'm just looking inside now. You have to move it up as much as possible, slowly, till your sample is in focus. Sometimes it goes in and out of focus pretty easily, so you have to be very mindful of when it becomes in focus. Especially on this device, the focus might be a bit tricky. Okay, it is in focus now. I can actually see my dent. We are not able to record the inside of the visor, but we'll make sure we find something online so you can actually see your indent. The last part of the lab is the rubber hardness test. We are going to give you this Shore Type A durometers. These are going to help us do the hardness measurements. You want to turn this on first thing you do, and the second you do is you want to zero this. They usually are going to be zeroed. We are going to give you a couple of rubber samples, and so you simply put the durometer on it, read the value, and the correct hardness values are given in the sample kit. We have many of these. We have the purple, brown, different types of rubber material. You have to keep in mind that you have to make a couple of different measurements so you have enough data points for your statistical analysis. And this will conclude the lab 1 of the Aerospace and Mechanical Engineering Lab 1 course. Thank you for watching the video. Please let us know if you have any questions or concerns, and keep in mind the statistical analysis and finding a confidence interval is a huge part of any lab. Just reporting one number is not going to be enough for your calculations. And if you do have a question, again, please reach out to us. See you for the next lab.